going to share my screen, and then we can all right, you guys can see all this? I figure for these ones we can kind of go down through the list and see if there's any aspects of it that you have any burning questions on, and then for something like OSPF or just the routing table, kind of I can pull up the equipment that I have and kind of give you that visual to maybe we go over something that was already gone over, or maybe just a different way. Plus you have that whole interactive thing, so you can't ask the guy any questions. So actually, you know what, since this is all about the routing table, let's pull it up. So one of the switch / routers that I have, everyone know how to like bring up the routing table?
Roger, it's just a show IP route, right?
That glorious thing that you have here. And so first off, we have those routing protocol codes. That's going to be everything up here. Nice little cheat sheet for everything that's going to follow. The prefix, this section here, as far as like what what the network is, and then the network mask. Then next hop is going to be after your via, right? So it's either going to be a physical interface if it's a directly connected route, or and then via this is your next hop that it will take. Administrative distance. Anyone know where administrative distance is in this?
Isn't it like the 90 and the 110 to 170 that I'm seeing on there?
Correct. Yes. So this is going to be your administrative distance's first number in the brackets. That's determined by, again, what the source is, and that's down here where is a whole another section on administrative distance. But yeah, so this is your administrative distance here, and then what is this number right after administrative distance?
Is that the cost? I might be wrong on that.
Well, so the broad term is it's the metric, right? So cost is the metric that OSPF has. Distance is the metric that EIGRP uses. Hops is the metric that RIP uses. So metric is the overarching term for the calculation that particular routing protocol uses to determine how far away a network is. So yeah, 170 is the EIGRP external administrative distance, and then 28,416 is the distance or metric that EIGRP has for that particular network. And here, 110 is the AD for OSPF, and 20 is the cost for OSPF. And then gateway of last resort is up here, and this is gateway of last resort is just your default route, right? So if I don't have any route for it in here in my routing table, then this is a match all, so that if you don't have that, then any packets with a destination address that isn't otherwise in your routing table will just get dumped, and that's no bueno. You can't expect to have routing entries for every possible network that exists everywhere. So gateway of last resort, very, very important. And you can see here that I'm actually sharing it across my network. You don't have to necessarily configure it statically on every router. I'm not sure if that's something that they went over, but any questions on those on 3.1 type stuff?
Hey, Sean, so if you see an IP address like 0.0.0.0, is that just like this is for any IP address that comes in?
Yeah, so we call it the quad zero. So the quad zero route is your default route. So it's meant to just be any IP address that comes in. Again, like so in 3.2, you can see 3.2.8 is longest match, right? So it will follow like if you are trying if it follows within the 3.3.3.3 address or that network, then it will follow that. But if it doesn't, let's say it's for 192.168.10.0, well, I don't have a match for that. So the quad zero route is what it would then match because it's that just fail safe. And then, hey, I don't know about this at all, but send it to this guy and hopefully he knows about it. And you just kind of have the stepped hierarchy of your default routes until you eventually get to a router that should know about it. Does that make sense?
Yeah, yeah, that makes sense.
Okay. Um, yeah, so that's what that quad zero is. So getting to longest match just means that because the router has gets this packet has to determine what to do with it, right? So the first thing it looks at, for anything else is what is the most specific route that I have for it. So longest match, most specific, same way. So it will take a slash, 26. And if there's a slash 26 in here, then it would take that over a slash 24. And it would take a slash 32 over slash 26, so on and so forth. So that is the first thing that it would go for. Now, the next point, administrative distance, that is your tiebreaker if you have two competing routes that are the same length. So if you have two slash 24 routes, then administrative distance comes into play to be that tiebreaker. So if you have uh, a static route and a route from a routing protocol, then it needs to determine which one of those I'm going to follow, right? Administrative distance is that mechanism. Zero is connected, one is static by default. We'll actually get into floating statics later on, but yeah, one is static by default. If you just hit enter after doing the IP route, I believe Tim, you had that question. And then you have the routing protocols that then have their own respective administrative distances. 20 is BGP, 90 is EIGRP internal. It's actually the only routing protocol that has different administrative distances. So you can see right here that these internal EIGRP routes are 90, but this external EIGRP route is 170. And that's a loop prevention mechanism so that if it learns something from outside of EIGRP natively, then it won't have to compete with if that route is potentially also known internally through EIGRP. 110 is OSPF, 120 is RIP. Like I said, 170 is EIGRP external, and then I want to say internal BGP, which doesn't really matter for you guys. I don't think they test you on it, is 200, I believe. Yeah, those are your main ones that kind of hierarchy administrative distances, and that's just the trustworthiness of the router. Like a directly connected is the most trustworthy because it's physically hanging on that router. Static is by default one because administrators should know what they're doing when it comes to configuring their routes. I can tell you from experience this oftentimes is not the case, but you kind of have to go somewhere, right? So it's a one by default, and then you have your different routing protocols. So Cisco was kind of integral in the creation of a lot of this stuff, so I think that's how they got their EIGRP to be more trustworthy than OSPF. But yeah, so it's also important to know, right? So let's say you're running both EIGRP and OSPF, like I am on this router. That's why a lot of these are showing up as EIGRP when I have them enabled for OSPF as well. But your router is your routing table is your best routes. It's not every route that the router knows about. It's just the best routes in any given scenario. So that's these EIGRP routes have won via administrative distance. So that's why they're in the routing table versus OSPF. And then routing protocol metric is more so just, again, how that routing protocol is kind of figuring out what the distance is to it. There's, OSPF has, like I said, cost, and it uses the SPF algorithm, also known as the Dijkstra algorithm. And yeah, so I don't think they get, the thing is more so just about knowing that that metric thing is there. I could go on forever about like how the routing protocols actually determine that, but I don't think you're gonna find it as fun as I do. So we'll kind of skip that. Configure and verify IPv4. So default route, that's this gateway of last resort. Network route. Static routing. Okay, so we need to go. I have any? No, I think it's on this one. So these are your static routes, right? So these are how they're configured. The IP route command, and it is the this is the network that you're putting in the route for. Like the point below it says host route. So if you did this for it, there's like a /22 route, you can 100% do that. So let's say I was trying to get to 10.10.10.5 is a computer, and I wanted to specify that specifically. It could be reasons for doing that. That's the only difference between how this route is kind of put out. You would just do the full IP address and then make this for 255s. And that would be a /32 or a host route, and then whatever the next hop is. Floating static is what I talked to him about in one of his questions. So again, if you put in these routes and you just hit enter, it has that default administrative distance of 1, which 9 times out of 10 is going to make it take precedence, right? So what you can do with a floating static route is configure an administrative distance at the end of this. So rather than hitting enter after you've input this, actually here, let's for this, here you can put the distance metric for this route. So say you're running OSPF, which has an administrative distance of 110, you could set this up for like 150, and then that would let you have that static route in there for as a backup, right? Let's say OSPF ends up crapping out, but you have some critical path that you need to maintain, even if OSPF has a hiccup, and the path that would kind of need to take. You can end up putting in something like this to be there. If OSPF drops out, then this route would now become the best route for that and go into the routing table, and that traffic would still be able to progress. Any questions? Bueller. All right. All right. Then OSPF. Very, very, very fun. So OSPF has 2 different ways that you can configure a lot of stuff with it. A lot of it is still under the routing process. So if you do not raw Turks. So here's what I did for you at JRP. But so here is your OSPF router process, and this is now kind of like known as like the old way to do it, but it's just router OSPF and then the process ID. Important to know that this process ID is locally significant and does not need to match on your other routers in order to set up neighborships. So just like this number in EIGRP 100% has to match. This one is just a differentiator because technically you could run separate OSPF processes. I don't know why you would, but it is possible. So if you're feeling froggy, then have at it.
Is it best practice? Is it best practices to have it at the same number at the end there?
I mean, I guess it's most common just because, to kind of like have things be, that sense of uniformity, but there's no best practice for it because it 100% does not matter. So I know that when I do it, I typically use the same process ID, but that is just, I don't know. So when I'm going and configuring multiple routers, I know that it's just router OSPF1 or, whatever. But there's no like, oh, you definitely should be doing it this way. I would say do it because it's easier, but you can do it however you want when it comes to that process ID. To establish neighbor adjacencies, you have two different ways that you can do it. I've done it the way with network statements. So network statements accomplish two things, and I want to kind of dispel a myth that somehow kind of gets perpetuated over the years. I've seen a lot with my guys is that you think network statements are going to be how you broadcast or advertise networks that you have, and that's not the case. So like this network statement of 192.168 doesn't mean that I'm saying I have the 192.168 /16 network. It means that any interface that's on this router that falls within that range. So anything that has 192.168 anything on my router will participate in OSPF and be in area 0. That's all that means. Now, consequently with that, the network that is on that interface will be subsequently advertised. But it's a lot of people think that they need to craft a network statement in accordance to how they want stuff advertised, and that's not the case. So you can do umbrella network statements like this, but you can do them as specific as you want. You can do umbrella ones. It depends on, you also don't want to, let's say you don't want all of your interfaces to be participating in OSPF, then that may be an instance where you want to get more specific with it. But the other way that you can do it is you can also do it on an interface level. So if you didn't want to do a network statement, you wanted to just enable the interface in OSPF, it would accomplish the same goal. So this is another way for you to be very specific with what interfaces you're doing in OSPF. So it'd be like sorry, I haven't done this. I haven't done it on an interface in a while.
So if you do it on an interface, will it like gig 01, will that still affect like gig 01.1, gig 01.2? Will it affect all those as well? All the sub interfaces?
So again, so you're talking about the router on a stick scenario, right?
Roger, yeah.
So remember, it only works on interfaces that are layer 3, or and more importantly, interfaces that have an IP address associated to it. So if you configure on the physical interfaces, but you're running sub interfaces, then it won't actually do anything.
Got it. Okay.
So you would need to configure on every sub interface, every interface that has that IP address configured on it, in order to actually establish a neighborship. Because I guess technically you would be sending out hellos over that physical interface, but since there's no IP address and therefore no subnet, configured for it, there'd be no way for them to actually establish a neighborship via IP because there's no real IP presence on that physical interface. Huh. Oh, I'm so used to having IP OSPF. My bad. Yeah, this is where you say your network type if you want to specify it. Okay. So yeah, you'd be OSPF 1, IPv4 area 0, and that would perform the same function as doing the network statement. And again, don't be afraid to question mark your way through it. It's I still do it all the time, obviously. I haven't had to configure OSPF like on a actual production network in quite some time. So the only time I mess with OSPF is for funsies. But yeah, so those are the two ways that you can do that neighbor adjacency. Now, when talking about point to point, the biggest kind of if you have like true point to point networks, then it's a simplification process so that that only these two routers are going to be. Yeah, let me. So this is the network that I'm kind of using for this. So I have these all just set up in broadcast mode. So these guys are actually neighbored up even though they're not connected with each other because they're all in the same area. So it's just about knowing that you have the multiple different options. OSPF is very, very flexible because it's that open standard. It's meant to kind of work at a bunch of different scenarios. So situations like this where broadcast is probably just easier because you want all these routers to kind of know about everything going on and then kind of bring it down with your areas. But you could also have it where you want stuff to just be point to point. So you can configure it like on here where the network, you set it to broadcast or point to point. And so these guys would only be configuring out via that link and not, transitively like to this router. If that makes sense. Yes, no, maybe.
Yeah, that makes sense.
Okay. Point to multi-point really don't. It's very kind of exotic connecting. Back in the day with like frame relay, you would do point to multi-point. You're doing something like DMVPN, then you could be doing something like that, but you really don't have to mess with it much. And non-broadcast, that's more of an old school way. Back when we were having like serial links for a lot of things, that's usually where NVMe were. So, but there's still, I'm sure that they're still out there somewhere, so it's still an option. But let's go back to the broadcast and DR and BDR selection. You guys understood kind of what that was about, the designated router and backup designated router. Okay, so actually, let me go back to this. So for any given area, you have what's known as a designated router, and that's kind of the focal point for all LSAs or link state advertisements for a particular area. So all link state advertisements, everything that's going on, everything that happens, you kind of have to have someone in charge of that, and that's what the DR is for. And that's another reason why you may want to do point to point. If it's very simple like that, then you won't have a DR selection because it's just you and another guy. We don't need to figure out who's going to be in charge of 50 routers when it's just the two of us. So DR and BDR, BDR is just there for backup, but it's all about priority. And the problem with OSPF DR selection is that, yes, there's a priority involved, and you can eliminate routers from even being considered. But a lot of times it just depends on which router comes up first. Because if a router comes up and there's no one to compete with him, then he becomes the DR, and you can't preempt a DR. So let's say switch 1 comes up, then switch 1 comes up, no one else has yet, then he's the DR. Let's say switch 2 is actually configured to have a better priority so that he should be DR, but he came up later. He can't usurp switch 1, so he would, most likely be the BDR, but this guy would still be the DR. And then you'd have to like wait for all of them to come up and kind of like go in there. It's actually kind of a pain in the butt. So normally what you'll do is you'll set whichever one's for DR and BDR and remove the other ones from being eligible to participate in that election process, so that it's just not possible for them to do it. And then at least you kind of narrowed it down. That's not the book answer, but that's how it kind of works in real life. And the way that you can, I'm pretty sure it's like where it would show you the priority you have for DR. Fortunately, there's so many different, there's a lot of information with this. But you can kind of see who your DR and BDR is by showing first. And so here you see you have full neighborship. That this guy is so I did loopbacks, so it's more easy to determine who's who. But so 1.1 is this switch here, and he's a DR other, which means that he's not a DR or a BDR. So switch 3 is the BDR, and so process of elimination means that switch 4 is the DR. So switch them on. That's how you can kind of determine who's who. But
hey Sean, so if switch 4 is the DR, why doesn't it show up in that list on there?
Here?
Mm-hmm.
It's because it's telling you the state of the neighbor that it's connected to. So,
okay.
So that's
okay. Yeah, I didn't realize you were in on switch 4. That's my bad.
Yeah, so I'm on switch 4. This is its neighbor table, so it's all the other routers saying what their role is.
Okay, Roger.
And then so router ID is something that plays much more into OSPF than other routing protocols, because all of the LSAs that a router sends out have their router ID tied to it, and it goes into the, I can show you the OSPF database. This is where it shows you everything about all of the LSAs it has, or at least they advertise. These are the different kinds of LSAs. So when you see here in link ID and advertising router is that router ID. And so because you end up doing a lot of your kind of troubleshooting or verification of your architecture in commands like this, it's highly recommended that you either statically assign your router ID, which would be under the routing process, or configuring a loopback, because the way that if you don't statically configure a router ID in OSPF, then it has two ways that it will do. It will first look at the highest IP address of any loopback interface and select that, or if no loopback interface is present, then it will do the highest IP address on any physical interface. So Configuring a loopback is a way to do it, or you can actually go in. Sorry, I don't multitask very well. The router ID, and this is where you would select your. This is where you would statically configure it. Now, just know that if you've stood up OSPF and it's established its neighborships, and you set this router ID after, then you would actually need to tear down OSPF in order for it to come back up with the router ID that you statically configured. So that would cause an outage while it tears down OSPF, builds it back up. Okay, is that kind of where, I mean, OSPF is a very, very complicated process, but you know, you don't need to know all the ins and outs for the CCNA. CCNP is where you definitely need to know way more about OSPF. But this kind of making sense? Am I just telling you what you guys already learned from the videos?
Yeah, it's making sense. It's good to hear it a little bit more elaborated on.
Okay. Yeah, just layer 3 is where most of the fun happens, but it's also, you know, infinitely more complicated than layer 2 is. Layer 2 is a lot more simple when, you know, as far as how decisions are made, the complexity of the various protocols that you're running. Layer 3 gets very in depth sometimes. Okay, and then describe the purpose of first hop redundancy protocols. So I have them configured on these ports. Let me pull this up again. So switch 1 and switch 2, I have running HSRP, which is a first hop redundancy protocol. And of course, I logged into switch 3 to show you that. So the purpose of first hop redundancy protocol is very simple. It's for redundancy, right? So it's for statically configured IP addressing, so that's to say, like, next hop IP addresses for routes, default gateways configured on infrastructure, and also computers. You statically configure those IP addresses. So if you end up wanting to stand up another router, well, you can't have them both on the same IP, or else that would be a duplicate IP addressing that would cause, you know, problems. So what first hop redundancy protocols do is it allows devices to be paired up, but have their own IP address, but also have a virtual IP address that they can respond to depending on who is actively, you know, acting as that router for, you know, whatever group that you're in. So your first hop redundancy protocols are HSRP, or Hot Standby Routing Protocol. Sorry, Router Protocol. That's the Cisco proprietary one. You have VRRP, which is Virtual Router Redundancy Protocol, and that's the open standard version. It's a lot like HSRP. And then you have GLBP, which is Gateway Load Balancing Protocol, and that's a Cisco proprietary one as well. And that's one where you can actually have multiple routers, like, responding to the same IP at the same time. It's yes, it works kind of like port channeling, where it ends up spreading the traffic over multiple links to have multiple routers operating at the same time. I've actually never seen that protocol used in the wild. Cisco doesn't even really talk about it much anymore. I think it's just too complicated and too problematic as far as the infrastructure involved, besides the routers actually running. So really, you just see HSRP and VRRP. So I'm running HSRP on this one. So I configured it on here. A very simplistic configuration, but in iOS and iOS XE, the configuration for HSRP is the standby command. Now in NXOS, they changed it to HSRP as the command. So if this was an NXOS device instead of standby, this would say HSRP. So that's your intro command. It's all done under the interface. After that is the group number. For VLANs, it's just smart to leave it as the same VLAN number for troubleshooting purposes and just kind of keeping everything straight. You can run HSRP or VRRP like on these physical interfaces. You can run them, these two physical interfaces in a group as well. But most likely you usually just see it on VLAN. So this IP command and this is where you actually set up that virtual IP that both routers will be operating under as far as, so whichever is the active router for this, do this by show, again, in iOS XE, it shows standby, and in XOS, it shows HSRP. So, do this. So these are the two interfaces that I have running HSRP. For VLAN 2, the state here is active, so the active router is local, means that the switch 1 is going to answer to this 2.1. It's going to be the active router for that VLAN. Switch 2 is the standby router. So it will be just sitting there waiting, and if switch 1 goes down, switch 2 would take over and become the active router for that group. Then VLAN 3, it's opposite. It's typical to do that, so that way you don't have one router doing all the work and the other one just sitting there waiting for something bad to happen. If you split them, then both can be acting as the active router for half of your layer 3 traffic, and that way you're getting something out of both of them. And that's, I mean, that's probably more than you needed to know, but I want to just give you a little bit. But yeah, that's the purpose of it. Any questions? We good under IP connectivity?
I think we're good, Sean, for IP connectivity.
Okay. And just remember, like this is the highest percentage of any group on this test. So that's, again, another reason why I'm kind of going into this much more in depth than we have on other ones, because this is going to be the, out of any other group, the one where you're going to see the most stuff on. So, all right, IP services. Is Matthew still?
I got back on. I literally no clue what happened. Just randomly disconnected me from the internet, and I'm back up again.
Okay.
Yes, it's been doing that to me too. Sean, is there a way we can reach this site so we can see what areas we should focus on so we're not going in dark?
This one right here that my screen is on?
Yeah, that one.
Yeah, I sent it to you in the first week, but it's all there's actually a PDF for this exact thing that I have attached in the Teams page. So if you go on there and go under files, and it should be class materials, you'll see there's a PDF in there that has this exact information on it.
All right, sounds good. Thank you.
Yeah, but you can also go to, like I said, if you just go and Google CCNA exam topics, that'll take you to this learning network page that also has it. So it's, depending on how you want it, it's easier for me to pull up a web page than a PDF every time, but it's also kind of nice to have the PDF in case, I don't know, say the website goes down or whatever. But yeah. Now for this section, really not too much as far as by showing you on equipment, but because again, it's only 10% of the test, so it's more so just about being familiar with them. This one I wanted to kind of see if there were any, areas that you wanted to kind of focus on or have questions about, because we're also kind of getting towards the end, so I didn't want to waste a whole lot of time on something that you may not really care about going over. Wow, you guys are just super participative today. I'm gonna need you to dial back. Can I get a word in, please? Is that possible? Oh, tough crowd. All right. Um, for Nat is something that kind of hit or miss as far as how often you end up needing to run it. But the big thing to remember with it is so you have your inside source and your inside and your outside. So your outside is going to be your public IP that you're using, whether it's you're doing static NAT, dynamic NAT, or HAT, or also known as NAT overload. Your outside is going to be that public IP that you end up using to actually traverse the internet. Your inside is going to usually be that private IP addressing, whether it's the 10 network from 192.168 that you end up having for your host, but it allows you to use minimal public IP addresses, but still end up having that external connectivity. So you can do that using pools. So that would mean that you're most likely doing dynamic NAT, which is kind of weird that they're asking you about that because really, well, static is fairly common, but that's mostly for servers where you want it to always have this IP address. It's a one-to-one situation. Whereas pools is, let's say you have 10 public IPs, then you could have, up to 10 devices connected on the internet with that, but they wouldn't be statically configured for it. Most commonly is dynamic net or not NAT overload or PAT, where you can use like a single IP address and just use port assignments to end up having that external connection. But it allows you to use much fewer IP addresses. For NTP, it's client server mode. I can show you this real quick. It's not. So your NTP is always going to be at the bottom of your configuration on your devices. So it's all just the where you can do when you configure NTP server, that means that you're telling the switcher router who it needs to point to as an authoritative, NTP source. NTP master allows you to have a switch act as a NTP source. So it's actually fairly common for you to do this, where you would have one device, like your core router or something, your core switch, point through the firewall to get an external time source, and then have all of your internal devices point to that core router, and it acts as an NTP relay. So that way you don't have to have every single device internal to your network point to an outside source. You can have them, all of your infrastructure point to that core router, and that core router points to the external NTP server. So now you may also need to do authentication. If you guys end up having to go with STIGs, then you know that you do need to do that. So you would do NTP authenticate, the key that you're using, and also trusted key saying what number it is. Access group is also something that you can configure if you want to limit what devices are able to connect, regardless of whether they have an authentication key. You can use the access group to kind of limit who's able to connect to your router for NTP purposes. The role of DHCP is dynamic host configuration protocol. That's a way for you to share both an IP address and other things like DNS. You can use it for VoIP phones where you can send TFTP information. There's a lot of different things you can send through DHCP. It's most commonly just used as a way to get your computers up and on the network without having to go and statically configure everyone. But that is the purpose of it. Now, kind of cover when start talking about DHCP client and relay. The reason why you need a relay is because DHCP is a broadcast, and routers do not forward broadcast. So if you have a client hanging off of here and you have a DHCP server hanging off of here, for instance, and this is layer 3, then that broadcast for the DHCP discover message would get killed and that computer would never get an address. So you want to do a relay on the interface that's closest to the host machine that would be initiating that DHCP traffic. So let's say this is on a VLAN. On that VLAN interface is where you can configure the relay. And what that does is it sees that DHCP discover message, which is the broadcast, and converts it into unicast and points it directly to your DHCP server. So that way you don't have to have a DHCP server on every single subnet. DNS, domain name service, is just so that you can have canonical names that are easier to remember and have them point to a corresponding IP address. So that's why Google is Google.com, but you don't know the IP address that it's on because nobody got time for that. Function of SNMP, Simple Network Management Protocol. That is a means for allowing you to get different aspects of your network devices. It gets you, how is the CPU doing? How's the memory utilization? What version of software is it running? You can actually push configurations using SNMP. So it's just a very good way of managing your network. And you can usually, a third-party software like SolarWinds is a big one that people use. Cisco has some done with Prime Infrastructure. There's a bunch of different SNMP programs that you can use to manage your network.
Hey, Sean.
Yes.
So with the DNS, how do you assign that to an IP address? Like how does the computer know when you type in Google to go to whatever Google's IP address is?
So in your, either if you statically configure or use DHCP, one of the fields that you would send out to that computer is DNS settings. So what server is it going to be using for DNS queries? Now for your internal configurations or your internal computers, most likely that DNS is going to be on the domain controller. So that domain controller will have what's known as internal DNS entry, but typically that domain controller will then point to an external DNS server of some kind, and this is kind of the hierarchical structure of DNS, where it goes domain controller, then external DNS. And when you start to see these, like how an IP address or a web address is kind of laid out, it's Cisco.com. So .com is, well, actually, after .com, there's technically a dot after that you don't see. But that dot at the end of com is the highest level domain in as far as the DNS hierarchy. So then .com is the next highest, and that will be on par with .org and .gov and .bz or whatever there's those top level domains. And then below that you would have things like Cisco.com or so you have .mil, right? So af.mil would be subordinate to .mil. And then us.af.mil would be subordinate to .af, and that's kind of the hierarchical structure for DNS. So I guess the long way of answering your question, on that computer, it points to the domain controller. It either has an entry that it's cached, or if it doesn't, then it would do a request to whoever the domain controller has configured as its name server. And eventually, till you get to a server that has an entry for that, it kind of acts as like a gateway of last resort, where eventually you're going to get to a router that has that network. Same thing for DNS. Eventually, you're going to get to a server that has an entry for that address, if it exists.
All right. Okay, that makes sense. Thank
you. Good question, because it's so definitely something to know how that works. So when you're kind of working on it. syslog features, it kind of depends on your scenario as far as like how you're going to configure it. But show log is where it shows all of this system logging features, different things as far as like if routing is going up or down or not. If someone made a configuration change, HSRP change state, then you can all sorts of messages there. But these all fall into different categories, right? You have all the way from critical to debugging. I think is the lowest protocol or lowest priority level. So you have critical. I think it's high, medium, low. Actually, I think there's a series in there. And all these different messages have these different hierarchies, and you can set what level that you want to be collecting syslog on, right? So maybe you don't care about informational type stuff. You don't want that just clogging your system log. So you can set that inside the here would say like what you say like the severity level, the size, but yeah, these are the different like critical informational notification warnings, errors, emergencies. Oh yeah, so here's the number right here. So yeah, these are the various different levels, and you can use that as typically you want everything, and then you use a logging server to end up kind of sifting through it. But you got to just be careful with this, so you're not potentially excluding log messages that may be necessary for you. It may not be world changing, but you can have small problems that end up becoming bigger problems. If anyone needs information on this QoS stuff, I'm not 100% familiar with it, so I could look it up and answer it for you. Just kind of someone let me know if they're really having problems understanding this part. Configure network devices for remote access. The big thing is that for SSH, you need to develop keys, and to develop keys, you need to have. There are some prerequisites for that. So you end up needing to establish a host name. So it can't just be switch. It has to have a differentiated configured host name on it, and then also has to have a domain name associated with it. So it's that kind of fully qualified domain name. So you would need to do switch one, and then IP domain dash name, and then right. So now this has a full name of switch1.lab.local. And then that allows you to go create RSA keys modulus 2040. And that allows you to generate keys. Once keys are generated, then your device is able to use SSH. Now you have different commands like IP, SSH. Version 2, you typically want to do that, but then now this device is capable of making an SSH connection to it via PuTTY or whatever else. So those are the kind of prerequisites and what you would need to configure your network device. Now you can get into much more detail, like in your line VTY, as far as are you only allowing SSH and not telnet? You should, but then you can get into much more detail. But these are kind of the fundamental configurations necessary for SSH into your devices. And then describe the capabilities and functions of TFTP and FTP. The big thing is that using those to transfer information between your devices, right? So the most common thing that you would use is if you need to push out a new iOS version onto your devices, then you can use TFTP or FTP to do that. That's really the only purposes that I've used TFTP and FTP on devices. Is no other reason I've had actually to use those on the devices themselves. So and I think it's just described, so you don't have to worry about how to configure it. That puts us at 11 o'clock. Did everyone feel good about the stuff that we went over? Any questions?
Yeah, it made sense. It cleared up a lot of questions for me.
Okay. Anybody else?
I just got to get my hands on and practice a little bit more. Well, at least with the commands. I finished up my Security Plus stuff this week, so I'm hoping to put a lot more focus in like next 3 weeks.
Okay. Yeah, it's definitely going to be, when you're not having to kind of split your time, then that's going to help a lot. And also like configuring it is going. I'm sure that Paul's running with the configuring the VLAN on the actual interface is going to help kind of like lodge that in your mind. Okay, well, if I'll stay on for a couple minutes if anyone does end up having any questions, but I will get this recording done and I'll put it up for on both YouTube, but now that we know that it's also available on the Files tab. So however you want to get to it, now you have multiple ways to access the recordings if you want. Thank you guys for coming out. Have a good weekend.
Hey, Sean, one quick question, and it's kind of off topic of what we discussed, but do you know how many questions roughly there are with the new CCNA, or how many there have been in the past?
I want to say one of my coworkers that recently took it said it was about 60, because it's all questions now. There's no labs.
Okay.
So I want to say it was in the neighborhood of 60, but don't quote me on that.
Okay, all right. Too easy. Thank you. Have a good weekend.
All right, you too, man. No problem, David. Thanks, Matt. Have a good one.